Example 8. Determine the support reactions on the member in the figure. The collar at A is fixed to the member and can slide vertically along the vertical shaft. We draw our free body diagram. Horizontal and then at inclined, which is 45 degrees, right? Let me zoom in. Okay, and this distance is 1 meter. 1 meter. Okay, and then from A, this is B. This is B here. Okay, and this is A. Now 1.5 from A. We have force, which is 900 Newton going down, and their measures in of the length is 1.5 meter each. Okay, now if you take note on the uploaded guide on how to view the reactions of the various supports, roller only support uh, vertical component that is always perpendicular to the surface. So therefore this is, let us have that as B sub Y. Okay, now at A, since this is a collar, it can only resist horizontal force that is going to the left. We call that A sub X. And since this is a collar again, there will be moment about A. So let us assume that the moment that the various forces caused to our point A is counterclockwise. Moment A. And before I forget, we have a at 1.5 from A, have a couple here, which is which is clockwise 500 Newton meter. Okay, so what we're going to do is that this is very straightforward. If we do summation x is equal to 0, assuming to the right positive, then A sub x is equal to 0. Okay, and then summation of forces y is equal to 0, assuming upward positive, then this should give us B sub y minus 900 Newton is equal to 0. So therefore B sub y is equal to 900 Newton. Okay, now for our lastly, because since there is an applied couple at which is accounting to 500 Newton meter, 1.5 from A, and then we also have going down force still at the same place, 900 Newton. It must be there is a moment that can resist all of these forces, and we also have B sub y. So what we're going to do moment summation about A is equal to 0, assuming counterclockwise positive. Now, of course, if we want to know the moment at A so that this structure will be in equilibriums, we will include the moment at A. So that would be, since we assume that the moment at A is counterclockwise, so therefore moment at A, and then we have 900 Newton and B sub y, which is also 900 Newton, 900 Newton, which is the load applied 1.5 from A, uh, causes a clockwise moment, and B sub Y causes a counterclockwise moment. So let us start with the positive ones. That is B sub Y. So that is plus B sub Y times its perpendicular distance. That is 1.5 plus 1.5. And then the horizontal component of our 1 meter, which is 1 meter cosine 45 degrees. So that is 3 plus 1.5 cosine 45 degrees. And then we do the subtractions now. That is 900 minus 900 times 1.5 minus our 500 Newton, because if you can observe again, it causes a clockwise moment. So that's minus 500 is equal to 0. So our moment about A is equal to uh, 500 plus 900 times 1.5 minus 900, right? Because B sub y is also 900 times 3 plus 1. That's not 1.5, but 1. Okay, let me erase this one, sorry. This is 1 cosine 45. So that's 1 cosine 45 degrees. Okay, so our moment about A is equal to 9, let us start with 3, 1 cosine 45, that's 0.7071, plus 3 times 900, and then 500 minus answer plus 900 times 1.5, and should give us negative 1,486.396103 Newton meter, which is, we write following the correct direction or with the correct sense. That's 1,486.396103 Newton meter clockwise. Oh, okay. Also, what you can do, you can also do the moment summation about point B. So of course, this time you will be considering A sub x because it has a perpendicular distance from B, which is the y component of our 1 meter. That's 1 meter times sine 45. So we can do that as well. But nevertheless, you will still end up with the same value, 1,486.396103 Newton meter clockwise.